Today we are doing a sequence reconstruction. We are given a permutation is a subsequence, okay, and the only supersequence. For example, okay, so what is the sum of lengths? Only shortest supersequence. Sum of length of sequence is 10 to 5. So essentially first you just check if their indices are smaller. So that's easy. That's the easy part. But then you have to check. Well, we have to check if there are, count of each element from here, I guess, and if there are extra, we remove it. And lastly, we want to check if we can swap the elements. So well, what would that mean for the graph? 1 in front of 3 and true. What the hell? And then if we have sequences 1 2 1 3 and then 2 3, so okay, so what the hell? Well, if I would have a cycle and then I have 3 4 in the end, if I remove one of these, if I remove like 1 2, what happens? Well, I can start from multiple points. Interesting. So basically what this does is we essentially make, are they unique? Okay, so basically this gives us a graph, and we have to decide if the graph has a singular ordering or multiple orderings. And I feel like if there is multiple components, no. If there is multiple starting elements, no. And then if there is multiple, so we want to count elements that have in degree 1 and out degree 0. So we just count the degrees, maybe. There should be a single element with some okay, let's do this. So minimum size, and then So first I do index num size I. Let's do this, why not? Okay, so first we get the indices, then we go for auto sequences. So what we want to check is, wait, but they are valid, so they are valid subsequences, so this is invalid to check. So we just do actually we just do in degree of n+1 and out degree of n+1 for auto. Now question is, what are the lengths of the sequences? Okay, as in sequences, let's do sequence for int I, sequence size I++, and now outdeg of sequence, let's call it int s1 sequel I minus 1 s2 sequel I. So out degree of s1++ and in degree of s2++ maybe, and now we want to do count, so int cent in cent out if index I0 cent in ++, if outdec I0 cent out ++, return cent in 1 cent in. Could there be a cyclic? Maybe this will work. One test case wrong. How is that possible? What? 1, 2, 1, 3, so 2 and 3 have to go after, and then my algorithm doesn't really work, I guess. I mean, why wouldn't this work? 1 before 2, or it's not the only sequence, because we have like 1, 2, 3, and they both go to 4. So we can go either way from here. What the hell? That seems absolutely wrong. I'm not sure what differentiates the cases. I mean, of course, I can just brute force this, but that wouldn't really work, would it? So if at any point, what do we want to check? So if we have this, that we end at the same, then what do we care about if we have multi-options, and when do we have multi-options? Well, if you have multiple kids, and because let's say it has 3 kids and then one arrow goes to each and then they go to the last one. Oh my days. If at any point the queue is larger than 1. So I want to make a graph. Let's just comment this vector. Technically I want to keep the in degrees. I just want to also make the S1 push back S2 and then if index I is 0, then on the q int q push I, while not q empty int v q front q pop. Wait, if q size over 1, return false for in the u in gv. Int v q front q pop. And now index u minus minus if index u 0 q push u return true. Boom. Oh sheesh. Okay, let's see. Great, this passes, so this should work. Okay, those are terrible test cases. Oh my days. Okay, let's I'm gonna come back in a bit to write the tutorial. Okay, I am back. I had to go away and finish learning for today. Let's pretend I know the stuff and whatever. You will know in what, 2 more days. We will see. I don't even need our degree actually. I think yeah, I don't need our degree. Should pass with better memory. Okay, let's write solution from this. So let's do topological sort. The subsequences give us lists of elements that have to be in that order in the final sequence. In the supersequence. Okay, so when can we not construct This sounds like topological sorting. Order vertices such that vi such that v is such that if v is occurs before u in the list in the ordering, no, if there is an edge vu, there has to be a v has to occur in the final ordering before u. Since we have the ordering, since we have orderings we want to satisfy, we satisfy we build a directed, we build a DAC from their constraints. Okay, and now we want to say when is there more than one super sequence, when we can make more than one topological ordering. The Kahn's algorithm for topological ordering works by always picking a single vertex from the list of vertices with current list of vertices currently having in degree 0. That already gives us the answer. When we, if we have if there is more than one what am I doing? If there, so that already gives us the answer. If there is more than one suitable vertex at any point, we cannot make a single super sequence of n plus m, since we do a simple, since we first count the in degrees of vertices and then do a simple BFS which takes of n plus m, where n is the number of vertices and m is the number of edges, which in our case is total length of subsequences, and m is the number of edges, which in our case is O of n, since we have a DAG. Are you sure? Okay. Since we create at most one edge for each element in each subsequence. We also do O1 work, updating in degrees, giving us the final time complexity of n, since we store in degrees of all nodes and the graph in an adjacency list, which takes up of n plus m, but we already know, but as already mentioned in the previous paragraph, m is equal to n. Therefore, the space complexity is of n. Whatever. Goodbye. I have to go, dude. Goodbye.